Welcome to Atomic Domain. Have you ever wondered if reality is bigger than what we can see? What if there is an entire world existing beyond our senses, beyond what we experience every day? Picture a reality where things move in ways that seem impossible, where a new dimension exists that we can't touch, feel, or even perceive, yet it's just as real as the world we... This journey will take you deep into a topic that pushes the limits of understanding, the fourth dimension. We'll explore how this dimension shapes our reality, why it's so difficult to comprehend, and how it may hold the answers to some of the universe's greatest mysteries. By the end of this video, you may see reality in a completely new light. Let's begin. What is a dimension? A dimension is a measurable aspect of space. It refers to the directions in which you can move or measure an object. Dimensions can exist in any direction, and each new dimension gives us more freedom to move. But how do we define dimensions? Let's start from the beginning. 0 dimensions OD, a point. A dimensionless object with no length, width, or height. It's just a location in space with no physical size or shape. 1 dimension 1D, a line. A straight path that extends infinitely in both directions. It has length, but no width or height. You can move forward or backward along this line, but there's no possibility of moving side to side or up and down. 2 dimensions to D, a flat plane. A sheet of paper, a drawing on a wall, or the screen of a video game. In this world, you can move up, down, left, and right. Everything in this world is flat and has length and width, but no height. 3 dimensions 3D, the world we live in. Our physical universe exists in 3D. We experience height, width, and depth. Our space has volume. We can move in all directions, forward, backward, left, right, up, and down. Everything around us exists in this 3-dimensional reality, from the air we breathe to the objects we touch. So, what about the 4th dimension? This is where things get really interesting. If the first 3 dimensions describe the space we live in, then the 4th dimension must be a new direction, one we can't directly perceive. Mathematically, the 4th dimension can be described as an additional coordinate in the system of space. Imagine an extra axis that doesn't fit into our 3D space. We can't see it with our eyes, but it's still a part of the underlying structure of reality. You might be thinking, if there's a 4th dimension, why can't I see it? Why don't I feel it? The answer lies in our perception. Humans have evolved to interact with and perceive only the 3 dimensions of space. We are limited by our biology and the way our brains process information. To understand dimensions beyond the 3rd one, we need to think differently, often using mathematical models and theoretical physics. In fact, we can make sense of higher dimensions by looking at how lower dimensions interact with each other. To better explain the 4th dimension, let's dive into how we can conceptualize moving from one dimension to the next. From 2D to 3D, a conceptual jump. To understand how the 4th dimension might work, let's think about the jump from 2D to 3D. Imagine a 2D world where everything exists on a flat surface. If you were a being in that world, you would only be able to move left, right, up, or down. Now, imagine a 3D object, a cube passing through that flat 2D world. From the perspective of the 2D being, they would see the cube appear and disappear. At first, they might see a single point. Then, as the cube moves through, they would see a line form and stretch. As the cube continues, the 2D beings would see more and more of the cube, eventually perceiving it as a square. But they could never fully understand the 3D shape of the cube because their reality is limited to 2 dimensions. If we're in a 3D world, how can we begin to understand the 4th dimension? Just like 2D beings can't fully perceive the 3D cube, we can't directly perceive the 4th spatial dimension. However, there are mathematical ways of representing it, and through these methods, we can gain insights into what the 4th dimension might be like. One of the tools we use is the Tesseract, the 4D analog of the cube. But before we dive into this mind-bending shape, let's take a moment to reflect on the limitations of our perception. We are bound by the 3D world, and even though higher dimensions may exist, we can't directly experience them with our senses. What is a tesseract? If a cube is the 3D version of a square, then the tesseract is the 4D version of a cube. In mathematics, the tesseract is also called a hypercube, a four-dimensional shape that extends beyond our perception. But how can we understand something that exists in four spatial dimensions when we can only see three? Let's start with an analogy. A square is made of 4 lines connected together. A cube is made of 6 squares connected together. A tesseract is made of 8 cubes connected together in 4 dimensions. That last statement might sound impossible to visualize, but it follows the same pattern. The tesseract is an extension of a cube into the 4th dimension, just like a cube is an extension of a square into the 3rd dimension. How do we see a tesseract? Since we can't directly see the 4th dimension, we can only represent the tesseract using 3D projections, just like how a shadow is a 2D projection of a 3D object. Imagine shining a light on a cube. The shadow it casts on a wall is a distorted, flattened version of the cube. In the same way, when we try to represent a tesseract in 3D space, we only see a distorted version of what it actually is.
One of the most famous representations of a tesseract looks like a cube inside another cube, connected at the edges. This isn't an actual 4D object, it's just a 3D projection of a 4D shape. The true form of a tesseract exists in a space beyond what we can directly observe. How would a 4D being see us? Now, let's turn the perspective around. If there were a 4D being, how would they see our world? Think back to how we, as 3D beings, observe a 2D world. We can see everything inside a 2D shape at once. If there was a 2D square on a piece of paper, a 2D being inside that square wouldn't be able to see outside of it. But we, as 3D beings, could look down and see everything inside without even entering the square. For a 4D being, our 3D world would appear the same way. A 4D being could see inside closed objects instantly, just as we can see inside a 2D shape drawn on paper. If a 4D being wanted to take something out of a locked box, they wouldn't have to open it, they could simply reach into the 4th dimension and pull it out. They would be able to see all sides of a 3D object at the same time, just as we can see an entire 2D shape at once. This concept might sound like science fiction, but it follows the logical pattern of dimensions. If we can see inside a 2D world from a higher dimension, then a 4D being could do the same to us. How would a 4D object appear in our world? Let's imagine what would happen if a 4D object passed through our 3D space. Think about a 3D sphere passing through a 2D world. The 2D beings in that world would see the sphere as a growing and shrinking circle as it moves through their plane. First, they would see a small dot as the bottom of the sphere touches their world. Then, the dot would grow into a larger circle as the sphere moves further in. At the middle, the circle would reach its largest size, the widest part of the sphere. As the sphere continues, the circle would start shrinking again until it disappears. This means that if a 4D sphere passed through our 3D world, we wouldn't see a 4D object all at once, we would only see cross-sections of it appearing and disappearing. First, we might see a small sphere appear out of nowhere. Then, it would grow larger, just like the 2D circle did. After reaching a maximum size, the sphere would start shrinking. Finally, it would disappear completely, leaving us with no explanation of where it went. This is exactly how a 4D object would interact with our world. It would seem to appear and disappear mysteriously, changing shape as it moved through our 3D space. Why do we call time the 4th dimension? At this point, you might have heard people say that time is the 4th dimension. But if we're talking about a spatial 4th dimension, how does time fit in? In physics, space-time is a combination of the 3 spatial dimensions and 1 time dimension. This idea comes from Einstein's theory of relativity, which showed that space and time are deeply connected.
In everyday life, we experience time as a one-way journey. We move from the past to the future. However, time acts as a dimension because we can describe an event using 4 coordinates x, y, z, t, where t represents time. Just like you need 3 coordinates to describe an object's location in space, you need a 4th coordinate, time, to describe when something happens. However, this doesn't mean time is the same as a spatial 4th dimension. In our discussion, we are focusing on the idea of a physical 4th dimension beyond length, width, and height, a space beyond what we can perceive. If a true 4th spatial dimension exists, it would be a direction we can't move in, just as a 2D being can't move up or down. The 4th dimension and Einstein's theory of relativity. Albert Einstein's theory of general relativity is one of the most groundbreaking theories in physics, and it introduces the concept of spacetime, a four-dimensional fabric that blends space and time together. Before Einstein, space and time were thought of as separate entities, but his theory showed that they are, in fact, interconnected, forming a unified 4D spacetime continuum. Here's how it works. Space consists of the three dimensions of length, width, and depth. Time is considered the fourth dimension, representing the progression of events from past to future. In this framework, gravity is not a force acting at a distance as Newton described, but rather a curvature in spacetime caused by the presence of mass. When an object has mass, it bends the fabric of spacetime, creating what we perceive as gravity. Imagine a heavy ball placed on a rubber sheet. The ball sinks into the sheet, creating a curve. If you roll a smaller ball across the sheet, it will move towards the heavier ball, not because there's an invisible force pulling it, but because the surface of the sheet is curved. In the same way, objects with mass bend spacetime, and other objects move in the curved spacetime, experiencing what we call gravity. How the fourth dimension affects time. In Einstein's theory, time isn't just a passive background. It behaves just like a spatial dimension but with different properties. Time is influenced by mass and gravity. Here's how. Time dilation. The closer an object is to a massive body like a planet or a black hole, the slower time moves for it compared to objects further away. Speed and time. As an object approaches the speed of light, time slows down for it relative to a stationary observer. This means that astronauts traveling near the speed of light would experience less time passing compared to people on Earth. This phenomenon has been proven experimentally with atomic clocks. For example, atomic clocks placed on airplanes or satellites run slightly faster or slower than those on Earth, depending on their velocity and gravitational influence. Thus, in Einstein's model, time and space are not rigid and unchanging. They are dynamic and can be warped, stretched, or compressed depending on speed, mass, and gravity. Quantum mechanics describes the behavior of particles at the smallest scales, things like atoms and subatomic particles. It's a world where classical physics breaks down and new rules apply. But how does the fourth dimension fit into quantum mechanics? At the heart of quantum mechanics is the idea that particles don't have precise positions or velocities until they are measured. Instead, they exist in a state of probability and can be in multiple places at once, a phenomenon called superposition. In this framework, the fourth dimension may be a way to explain quantum behavior. In certain interpretations of quantum mechanics, like the many-worlds theory, the universe splits into multiple realities every time a quantum event occurs. This suggests the existence of additional dimensions where different versions of reality could exist simultaneously. One interpretation is that time itself might behave differently at the quantum level, with particles moving not just forward but possibly backward in time or even sideways in higher dimensions. Quantum mechanics doesn't just challenge our understanding of space, it challenges our very concept of time itself. String theory and the fourth dimension. String theory is one of the most ambitious frameworks for explaining the universe at the most fundamental level. It suggests that the basic building blocks of nature aren't particles but tiny, vibrating strings. These strings can vibrate in different ways, and their vibrations determine the properties of particles like mass and charge. But how does the fourth dimension fit into string theory? According to string theory, there are many more dimensions than just the familiar three and time as the fourth. In fact, the theory suggests that there are up to 10 or 11 dimensions in total, but we only perceive 4 of them. The rest are hidden in ways we can't directly observe. These extra dimensions are thought to be curled up very tightly, so small that they are effectively invisible at human scales. Compactification, the additional dimensions predicted by string theory, are often said to be compactified. This means that while these dimensions exist, they are incredibly tiny, possibly at the Planck scale, the smallest scale of length in physics. Brains. In some versions of string theory, these extra dimensions might involve brains' multi-dimensional objects that can exist in higher dimensions. We live on a three-dimensional brain in a four-dimensional spacetime. While string theory is still very much in the realm of theoretical physics, it offers an elegant way to reconcile the quantum world with the cosmic scale and suggests that the universe might have many more dimensions than we can perceive. The fourth dimension in this context is just one piece of a much larger cosmic puzzle. Could the fourth dimension be real? At this point, you might be wondering, is the fourth dimension real? Can we prove it exists? The truth is, we don't fully know yet. Theoretical physics has provided models and equations that suggest higher dimensions exist and play a role in the fundamental structure of the universe. Experimental evidence is still sparse, but there are experiments, like those at CERN, trying to probe these ideas. Scientists are hoping that future discoveries, such as the detection of gravitational waves or the mysterious dark matter, may offer clues about the presence of extra dimensions. In short, the fourth dimension remains a hypothesis, an idea that might one day be confirmed or refuted by more advanced scientific theories or experiments. However, as we've seen from Einstein's work, the idea of a 4D spacetime has already reshaped our understanding of the universe in profound ways. The fourth dimension and the future of space exploration. The fourth dimension has long been the subject of theoretical physics, but how could it affect the future of space exploration? If we can unlock the mysteries of the fourth dimension, it could change everything about how we travel through the cosmos. Faster than light travel, according to theories that involve the fourth dimension, such as wormholes or spacetime warps, we might one day be able to travel faster than light. A wormhole, for example, could act as a shortcut through spacetime, connecting distant parts of the universe. Dimensional travel. By manipulating the fourth dimension, we might also be able to explore parallel universes or even access alternate realities. If we are in a 3D universe, it's possible that other 4D beings or civilizations could exist in higher dimensional space. Space agencies like NASA and private companies like SpaceX are already working on pushing the boundaries of space exploration. But in the future, if we understand and harness the power of the fourth dimension, it could radically alter our ability to explore distant galaxies, travel at relativistic speeds, and even visit other universes. Wormholes, a path to the fourth dimension. One of the most exciting concepts in physics that involves the fourth dimension is wormholes. A wormhole is a theoretical tunnel through spacetime that could connect distant points in the universe. Think of it like a shortcut through a higher dimensional space. It's called the Einstein-Rosen bridge and is often depicted in science fiction as a way to travel vast distances instantaneously. How it works: imagine spacetime as a 2D sheet of paper. If you fold that paper in half, the 2 points that were once far apart can now be connected by a hole in the middle. In higher dimensions, a wormhole works in a similar way by connecting distant points in space-time. The fourth dimension's role: to make wormholes stable and usable, they would likely require the manipulation of the fourth dimension, possibly to help stabilize the tunnel, so it doesn't collapse. If we could access the fourth dimension, wormholes might be more than just theoretical, they could become viable pathways for intergalactic travel. While wormholes are still very much in the realm of theoretical physics, they offer one of the most fascinating glimpses into how the fourth dimension could one day shape space travel. The multiverse theory and the fourth dimension. Another exciting area where the fourth dimension plays a central role is the multiverse theory. The idea behind the multiverse is that our universe is just one of many possible universes, each with its own laws of physics. The fourth dimension could be the key to understanding how these universes exist and interact. Many worlds' interpretation of quantum mechanics. One interpretation of quantum mechanics suggests that every time a quantum event occurs, the universe splits into two or more realities. These alternate realities could exist in higher dimensions, and the fourth dimension could provide a way to access or interact with them. Higher dimensional space. If the fourth dimension exists, it might allow us to travel between different timelines or realities. We could potentially access parallel universes by moving through higher dimensional spaces that are invisible to our current perception. If the multiverse theory is true, then the fourth dimension might be the link that connects our universe to an infinite number of others. The possibility of interacting with parallel worlds could open up a new frontier in cosmology and quantum physics. Higher dimensional technology and the fourth dimension. Imagine what kind of technology could be developed if we understood the fourth dimension. From advanced computing to energy generation, the potential applications are mind-blowing. Higher dimensional computing, one area where the fourth dimension could play a key role, is in computing. Quantum computers. Quantum computers already use the principles of quantum mechanics to perform calculations much faster than classical computers. But what if these computers could also utilize the fourth dimension? Quantum entanglement. If we understand the fourth dimension, it might allow for even more advanced forms of quantum entanglement. This could lead to computing systems that operate not just on three-dimensional principles, but on four-dimensional or even higher-dimensional logic. Parallel processing. In theory, a 4D computer could handle much more data simultaneously, using the extra dimension to store and process information in ways we cannot yet imagine. Energy manipulation and the fourth dimension. If we can manipulate the fourth dimension, we could potentially tap into new forms of energy generation. Tapping into higher dimensional energy. In higher dimensions, there could be energy sources that we can't access in our current three-dimensional world. By manipulating the fourth dimension, we might be able to harness this energy and use it for things like interstellar travel, advanced propulsion, and even sustainable energy on Earth. Energy from space-time. Some theories suggest that the fabric of space-time itself may hold vast amounts of energy that we could tap into. By manipulating the fourth dimension, it could be possible to extract energy from the very curvature of space-time itself, much like how black holes could, in theory, provide a way to extract energy through a process called Hawking radiation. While these ideas are speculative at this stage, the future of higher dimensional technology could fundamentally transform our civilization. How understanding the fourth dimension could change our reality. What happens if we can prove the existence of the fourth dimension and learn how to manipulate it? Reality itself could change. Understanding the fourth dimension could completely alter how we perceive reality. We might discover that the laws of physics aren't fixed and that higher dimensional spaces could allow us to bend space, alter time, and even access new realms of existence. Redefining human potential. The implications for human potential are profound. By tapping into higher dimensional spaces, we could unlock new abilities like moving through time or changing the fabric of reality itself. The limitations of our three-dimensional existence might no longer apply. In short, the discovery of the fourth dimension and our ability to manipulate it could represent the next giant leap in human evolution, allowing us to transcend our current limitations and open the door to infinite possibilities. The philosophical implications of the fourth dimension. Understanding the fourth dimension is not just a scientific breakthrough, it could also revolutionize how we think about the very nature of reality and our place in the cosmos. Time and free will. If the fourth dimension is a real, tangible part of our universe, it could challenge our very concept of time and free will. In a four-dimensional space-time continuum, time might not be the linear, flowing river we perceive it to be. Instead, time could be just another dimension where the past, present, and future all coexist in a more static way. Determinism versus free will. This could lead to a debate between determinism, the idea that events are predetermined, and free will, If all moments in time already exist, then free will might just be an illusion. Everything might be set in stone in the fourth dimension, and we are simply moving along a pre-existing timeline. On the other hand, if the fourth dimension is malleable, it might open up new possibilities for human agency and the ability to influence the future. The nature of consciousness, understanding the fourth dimension, might also influence how we view consciousness. What if our conscious awareness is tied to something greater existing in a higher dimensional space where time and space are intertwined? The fourth dimension might suggest that our conscious experiences could be influenced by higher dimensional forces, suggesting a much deeper connection between mind, body, and the universe. The role of higher dimensions in existence. For centuries, we have perceived the universe through the lens of three-dimensional space. But what if the nature of existence itself is far more complex? The fourth dimension could provide a window into a deeper, more intricate level of reality where our three-dimensional perceptions are just a small slice of an unfathomable whole. If we could perceive higher dimensions, we might understand existence as a vast, interconnected web where the boundaries between time, space, and matter blur. The impact on human evolution. If we could unlock the secrets of the fourth dimension, what might it mean for the future of humanity? Transcending human limitations. Right now, our understanding of space and time is limited by our perception as 3D beings. But what if the fourth dimension holds the key to transcending those limits? By understanding how to navigate the fourth dimension, we could potentially transcend the boundaries of our physical bodies. The future might bring possibilities such as mind uploading, where our consciousness could move beyond our physical bodies and exist in higher dimensional space, or the ability to manipulate time to enhance our mental and physical capacities. The evolution of technology and humanity. The fourth dimension might also guide the evolution of our technology. As we begin to understand higher dimensions, we might develop technologies that allow us to interact with these realms, leading to new innovations in areas like computing, communication, and even space travel. The next step in human evolution could be a leap not just in biology, but in our technological mastery over the dimensions themselves. Humanity could move from being limited by the physical constraints of the 3D world to manipulating the very fabric of space-time. New frontiers in human experience. Beyond the physical world, the fourth dimension could open up new frontiers in human experience. If we can interact with higher dimensional realms, we might explore deeper layers of consciousness, unlock new senses, and potentially experience existence in ways that we can't even imagine. We could live in ways that transcend our current understanding of reality and enter new states of being. The fourth dimension and the future of science and technology. The fourth dimension is more than just a theoretical idea. It has real potential to shape the future of science and technology in unimaginable ways. In this section, we'll explore how the fourth dimension could influence everything from space-time manipulation to scientific breakthroughs and advanced technologies. Manipulating space-time. As mentioned earlier, understanding the fourth dimension could lead to the ability to manipulate space-time itself. Imagine a future where we can bend spacetime to create wormholes, allowing us to travel vast distances across the universe. The concept of faster-than-light travel might become a reality, with the fourth dimension acting as the gateway to new realms of space exploration. Revolutionizing computing. The development of quantum computing is already pushing the boundaries of what we thought was possible in terms of processing power. But by incorporating the principles of the fourth dimension into computing, we could see an exponential leap forward in computational capabilities. A 4D computer might process data in ways unimaginable by today's standards, opening up new avenues for artificial intelligence, machine learning, and solving complex problems. Advances in communication. The fourth dimension could also revolutionize communication technology. If we can manipulate spacetime or tap into hidden dimensions, we could develop systems that allow for instantaneous communication across vast distances. Quantum communication systems that use entanglement and higher dimensional principles could change how we transmit information and make our current internet and telecommunications systems obsolete. The fourth dimension and the future of humanity's perception of reality. The philosophical and existential implications of the fourth dimension will likely be the most profound. If humanity succeeds in understanding and manipulating the fourth dimension, it will change how we perceive not only the universe but also reality itself. Shifting perspectives, if we could perceive the fourth dimension, we might no longer see the world the way we do now. The rigid laws of 3D spacetime would melt away, and we would enter a world where the boundaries of space and time are not as fixed as we once thought. Our understanding of existence could be radically altered. Human potential. The discovery of the fourth dimension might inspire a new renaissance in human thought and innovation. Much like how the discovery of the microscope and telescope revolutionized our understanding of the universe, understanding the fourth dimension could propel humanity into a new era of exploration both of the physical cosmos and of our own consciousness. A new era of exploration and understanding. Imagine a time in the future when we fully understand and can interact with the fourth dimension. What kind of world would that be? It would be a world where humanity is no longer confined by the limitations of our 3D perception. We could explore alternate timelines, interact with parallel universes, and potentially even reshape the fabric of reality itself. Throughout this deep exploration, we've uncovered the mysteries of the fourth dimension, a concept that challenges our understanding of reality and has the potential to reshape science, technology, and human perception. We began by defining dimensions and using analogies to understand higher dimensional spaces. We explored how a 4D world would function using the Tesseract as a guide and examined how 4D beings would perceive and interact with our 3D reality. From there, we connected the fourth dimension to time itself, uncovering how Einstein's theory of relativity treats time as a dimension woven into space. We looked at the mind-bending effects of time dilation, the warping of space-time, and how quantum mechanics and string theory suggest that extra dimensions may be hidden just beyond our perception. We then took a bold step into the future, speculating on how higher dimensional technology could revolutionize space exploration, communication, and computing. Could the fourth dimension unlock faster than light travel? Could it allow us to access wormholes and parallel universes? These questions push the boundaries of human imagination and scientific possibility. Finally, we reflected on the philosophical and existential implications of the fourth dimension. If time is simply another coordinate in spacetime, does that mean free will is an illusion? Could our consciousness exist in a higher dimensional state? And how would truly perceiving the fourth dimension transform human evolution? Key takeaways from our exploration. The Tesseract for D hypercube helps us visualize how higher dimensions might work. 4D beings could see inside closed 3D objects and perceive all angles at once. The fourth dimension's link to time suggests that past, present, and future may all exist simultaneously. Einstein's relativity treats time as the fourth dimension, and extreme speeds or gravity can warp it. Quantum mechanics and string theory hint that multiple hidden dimensions might shape our universe. Theoretical technologies like wormholes, 4D computing, and advanced energy manipulation could reshape the future. The fourth dimension challenges our perception of reality, possibly leading to a revolution in human thought, science, and exploration. The journey into the fourth dimension is far from over. While we may not yet have all the answers, the potential for discovery is limitless. Understanding higher dimensions could unlock a new frontier of human knowledge, reshaping our place in the cosmos and perhaps even allowing us to transcend the limits of space and time itself.